Good morning, everyone. Welcome to our next edition, or this edition of Power Hour. Today we are going to talk about Intercontrol Center Protocol, also known as ICCP. This is our latest protocol that we've added to our Orion products. Today we're just going to do a little bit of introduction, kind of a little bit background information on the protocol itself. And Sean Ryan will be going through the demonstration on the NCD interface. And I myself, Chia Carnegie, will provide the background information on the ICCP protocol. Just a reminder, we are still doing the t-shirt giveaway. Top 5 attentive attendees will be put into a draw. 3 will be pulled out, and we'll contact you via email to get your size, and we'll ship it up to you. Pretty short agenda today, so ICCP basics, and then Sean will be going through the server configuration as well as the client configuration on the NCD, and he'll provide more information on that. So a little bit of introduction to ICCP. ICCP stands for Intercontrol Center Communication Protocol. The emphasis here is intercontrol. So unlike other protocols that we've developed on the Orions, this one's more focused on control centers to other control centers. That's the most common application for it. We have seen applications where substations are using ICCP to send it to control centers as well instead of DMP3, but ICCP was designed mostly for communication between control centers. It is an international standard, and similar to other SCADA protocols, it send real-time data, but the unique thing is it also does send historical data, or it does support that functionality. It sends data over a wide area network, but when it was first introduced, it also supported peer-to-peer connections using dedicated lease lines. I don't think dedicated lease lines are very common anymore, more a wide area network, but it is possible to use ICCP as peer-to-peer. Communications between control centers are common, as well as communication from, let's say, control centers to their power plant, or regional system operators such as ISOs and TSOs. Those are common as well for using ICCP. Regional operators may also use ICCP to coordinate import and export of power between regions across major interties. So really anything that's is between utilities, between control different regions, ICCP is mostly often used. So as I mentioned, it can exchange real-time and historical data. So some examples of this is status, control data, measure values. So these are pretty common with what we've already been doing with other protocols. ICCP can support scheduling data, energy accounting data, operator messages, and those are kind of additional data that's not very commonly used in substations, so that's why we've never worked those, but ICCP can support those types of data because it's more at the upper SCADA level. Why is inter-utility communication needed? And overall, it's just to improve reliability. Allows utilities to have more visible what's going on, not just within their own grid, but other regions' grid. Detects disturbance, allow reconstruction, improves modeling capability, enhance operations, increases load management, allow it to be more efficient, and really just allow utilities to pool their resources and work together. So history of ICCP, prior to ICCP protocol, SCADA uses more proprietary protocols. So it's hard, let's say one utility uses one SCADA system and another utility uses another SCADA system. It was kind of hard to kind of talk to each other just because every SCADA system had their own proprietary protocol. And because of this, there was no standardization. So there was an effort developed to have an international standard to allow the data exchange between these control centers. Even though they have different SCADA systems, they can use ICCP to communicate because it's an international standard. In 1991, a working group was formed. They developed the standard and they performed the tests and so on. There's still a working group now, so similar to DNP3 or 61850, those working groups allow you to implement your ICCP devices or allow you to test them properly according to the standard. Official name for ICCP is IEC 60870-6, TASE.2. There was a TASE.1, but TASE.2 was added to ICCP standard because of the manufacturing message specification. So this is the MMS portion of the standard. This is a similar MMS that you can find on IEC 61850 protocol or standard. There are two main versions of ICCP. Version 1, also known as 1996-08. Version 2 is 2000-08. Just to be careful, if there's an interoperability issues with these two versions. So if you have version 1 as a server, but you have version 2 of the client or vice versa, there might be issues associated with that. So ensure that you have the right version for both client and server. The version that NovaTech implemented on Orions is version 2. It's just that it's more commonly used now, and based on our discussions of our customers, that's the most common version that they're using. Just a little bit background on the architecture of the protocol. So similar to any other protocol that if you had training on them, they always mention the OSI reference model. So for example, DNP3 uses only physical data link, transport, and application. ICCP is a little bit different than that. It actually uses all 7 layers. And really, it doesn't need to develop anything new from layer 1 to layer 6. It just used whatever was already existing. I'm not going to go into too much detail of the OSI reference model just because that'll be another hour, but what we want to reiterate here is ICCP just added on development onto the layer 7 itself, and then everything else underneath it was pretty much untouched or reused from before. So within the application layer 7, this is where the new ICCP standard was written, and then also the addition of MMS service is introduced in layer 7. Again, MMS is the same is used in 61850. What MMS allows is to enable data to be represented by name instead of numerical index. So what that means is that unlike DNP3 or Modbus, where each point has an address, and those address has to match between your slave and your master, or your client and your server, MMS allows ICCP to not have addressing. It uses naming instead. So it's similar to 61850, naming on your server of your points or your point tag has to be identical to the points on your client side when it's asking for the data. If it doesn't match up, it won't transfer the data. MMS handles the mechanics of the naming, listing, addressing variables, message controls, and interpretation. The ICCP standard does the object formatting and then the method for data request and reporting. So that just kind of breaks up those two services out on the layer 7 there. All right, so also on layer 7 is what we have, the application program interface, known as API. So similar to your apps on your phone. There's a lot of apps that have APIs so that they can connect their app to a different app. So similar to your banking app connects to PayPal or whatever. So these are little APIs are application that allows, so this could be, let's say, the Orion ICCP implementation, and we have our own API, and then those API will have to match up and so that they can connect to, let's say, an external SCADA database or an EMS application or real-time database and so on. So these APIs is actually not part of the standard. So vendors can implement their APIs very differently from one another. So even though the ICCP and the MMS matches the standard that's written, the APIs can be very different. So that introduces an interoperability thing that vendors have to work out. It is, so as mentioned, API is optional, does not mention in the specification. And then vendor implementation is free to choose how the API is suitable for their product. All right, so ICCP is very similar to DMP3 in that it is a client and server model. It can do, it allows the client or the master to initiate a request, and then the slave or the server will respond with the requested data. So that's pretty common to what we're all used to. But at the same time, it also supports unsolicited reports, so similar to DMP3 there. In the event that something happened, a point change, or periodically it can send data to the client without the client sending a request. So it works in both methods. And then a system can be a client and a server at the same time. So similar to DMP3, an Orion can act as a master and a server or slave. Here with ICCP, you can act as a client and a server at the same time. So in the event that, you know, the control center here can request data from ISO that the ISO either have or have from another utility, it can send data to the control center. So it can be a two-way street communication. In the ICCP, there's such thing as associations. So associations are just connections, and there can be multiple associations. For example, you can have one client but two servers, ICCP servers. So here we have Control Center 1 and Control Center 2, both sending data to this ISO, for example. Or you can also have multiple associations from one client to one client, sorry. And so from here, the control center can have two connections, ICCP connections to the ISO. And really what this does is allow higher priority data to maybe be sent more often. So in the event of unsolicited reports. And then lower priority can be sent less common. So that's available in ICCP protocol. And then there's mentions of bilateral tables in ICCP. So bilateral tables are rules and restrictions placed on the data being transferred. So similar to DMP3's slave and master point list, it just kind of have to match up, right? So on your DMP slave side, you have your point list, those point lists have to match up with the master side. So the bilateral rules kind of have that. It's not exactly the same. I think it has more restrictions on that. Your data has to match up, but as well the permissions associated with that data. So can the client read and write to it, or is it only read only, or has no access? So there's permissions placed on those points as well. Not only do you have the naming have to match up, it does have to have the permissions implemented. The bilateral tables on both the server and the client side has to be synchronized. And if they're not, data will not be able to transmit properly. All right, so ICCP, this is just kind of overview of the conformance blocks or that they support. So conformance blocks are a way of grouping ICCP objects together. So it's kind of similar to in DNP3 where you got your analog inputs, your digital outputs, your counters, your frozen counters, and so on. So conformance blocks is just a way of grouping those different types of data. Vendor does not need to implement all the conformance blocks. There's 9 in total. We're just going to provide a summary of those 9 just so that you're aware what's available. The only conformance blocks that the vendor needs to implement is conformance block 1. Everything else is optional. So conformance block 1 is status point, analog points, quality flags. So these are periodic system data. So very standard SCADA data that we're used to working with in DNP3, Modbus, and so on. So that's definitely understandable that conformance block 1 is required. Conformance block 2 is extended data set condition monitoring. That's a really long term, but really what it is can it support unsolicited reporting? Is there a mechanism to allow the client to send data to the server to send data to the client without being requested? So this is the unsolicited functionality. Because it's conformance block 2 is not mandatory, so a vendor doesn't have to implement that. Conformance block 3 is block data transfer. So this is quite interesting. This, instead of sending point by point, so similar to DNP3 where you're requesting data point by point, you can actually send block of data. So this allows you to have safe bandwidth in a sense, so that you're not just sending points as the event happens. You can say if any of the point changes in this block, send the whole block up, so that the client doesn't have to request for more data. All right, conformance block 4 is simple text and binary files, so that's very different from what we're used to for the substation kind of SCADA application. Conformance 5 is device control. So this is your digital outputs and your analog outputs, your on-off, trip close, raise lower, and so on. 6 is program control. So this is very interesting. I've never seen this in any other protocol. So this allows the client to remote control into the server. So this is almost remote entering access capability. So that's quite interesting there. Event reporting. So extended reporting for, let's say, error conditions, device state change at the server side. 8 is additional user objects, so it could be scheduling, accounting, outage, plant information, so extra information about the client or the server side. And then time series data. This is more archive data. So in the event that the server has some archive data, it can send that whole archive data to the client. So yeah, so that's a lot of different types of data. So what NovaTech has implemented so far for ICCP on the Orion is conformance block 1, 2, and 5. So this is your status, your analog. We do support unsolicited reporting, and then the controls. The reason why we did those 3 is this is what we've always been doing for DNP3, for Modbus 61850. All those other data, those are extra data that we've never worked with yet. And so this is our first implementation, and then also based on our customer feedback, this is what they need right now. As we have more users for ICCP, based on their feedback, let's say they want the archive data to be sent using for conformance block 9. So, you know, obviously if it's requested of us, we evaluate and so on, we'll do our design stage and we'll consider adding that in. But as of right now, our ICCP can support 1, 2, and 5. All right, so ICCP, as I mentioned, is quite old. 1991 is when the working groups started working on the standard, but really if you think about it, it's just as old as DNP3. But because it's not been implemented as widely as DNP3, there is a security I guess, flaw in that sense. The standard doesn't include a security definition. So if you look on the internet, if you research ICCP, there is a lot of articles in regard to security for ICCP. But as I mentioned, ICCP support APIs, which has optional components. And so when we implemented our API, we included a TLS encryption wrapper with it. So what that does is that all data that gets sent out will be wrapped and then encrypted. So when the client and the server has the same TLS certificates, they were able to unencrypt and read the data and so on. So we added security. So I don't want to scare people from not using ICCP. We did add security onto our implementation so that you don't have to worry about a security issue. Just a quick overview of the types of data that we support. So for inputs, we have single bit status point, double bit status point, analog, integer analog values, and floating analog values. And then for commands, we have binary controls, and we have integer set points and floating set points. So those are the types we support right now. And with that being said, I'll transfer my presentation over to Sean, who will be showing the interface on the NCD side.
Perfect. All right. Well, good morning, everybody. Hopefully you guys are seeing the screen here. So what we're going to be doing, as Chi said, is I'm going to be doing kind of the live demonstration aspect of how to configure ICCP within NCD3 here. So as Chi already alluded to, we're going to run through the configuration, obviously, of the ICCP server on the Orion. Then we're going to jump over to the configuration of the ICCP client on the Orion as well. And then we'll go into some of the details between, as far as once we get those configurations loaded onto the Orions, we're going to go ahead and look and see how the data values are transferring between them, likely go into the viewing of the communications between the two devices. And then lastly, we'll show some of the default files that are actually configured as part of NCD3 and building those default templates and how you can implement those toward building ICCP configurations for non-Orion devices when you have an Orion platform communicating to some other vendor using the ICCP protocol. So as we jump into this, Chi kind of just spoke about this, but I do have one little slide. This is just a little snippet from the user manual, actually. This goes into just a little more detail of what's supported within NCD3 and the Orion platform for how we can communicate with ICCP. But you'll notice up above, this isn't necessarily an all-inclusive list. We're going to be working with an LX on my example here, so that's supported, and we also can run this on the Orion IO as well. So what we're going to do is we're just going to jump right into NCD. And before we begin, you're going to notice in the lower right-hand corner that I'm actually running some beta, a beta version of the NCD software. So that's what's allowing me to show and demonstrate the ICCP client today. I believe everybody else that has version 3.36 is going to have the ICCP server at this point. But again, this will be coming soon. And if you want it now to start playing with it, again, we can make this beta available, but this will be supported in the next full version of NCD3. That also goes for the firmware as well on the Orions, is that both the ICCP server and client are supported at this point. It's just, again, you need to have the latest NCD to do that configuration. So as many of you should be aware, if you go to help documentation, you can go into this directory that's already installed on your own computer as part of the NCD software being installed. This just goes into your program files directory. And if you come down, you're actually going to see that, again, with that version 3.36 version of NCD, you're going to have a protocol ICP server. And in there, you can click, see the user manual, and this will cover the good bit of what we're going to show today as far as the server side goes. So keep that in your back pocket, keep that in mind. But as we jump out of this and back into NCD, I have a configuration open already, just called Orion LX base. There's nothing fancy about this configuration. This is just what we're going to use as a baseline. You'll see I have a network port here configured to talk directly to my Orion IO, and there's nothing fancy to this guy other than the fact that I have 8 analog inputs. We've got 32 binary inputs, and then we have some various trip close pulses and latches coming from this. So this is just going to serve as our example data set for sending data via over ICCP. Now, of course, in a normal configuration, hopefully you would have many different IOs, potentially many different relays, a lot of different line relays for the example of shared transmission, interconnect substations, etc. But we're just going to use these base points to begin with. So to start the overall configuration of ICCP, we're just going to go to Configure, Network, and then we're going to go Configure New Port, and we're going to find, in this case, the ICCP Server. So we'll click OK. And the first bit that comes up in here are the parameters of the overall port and the main connections. Now you'll see a few extra little buttons that we're going to come back to in more detail later, but we have the ability to add new domains, and then we have the global domain. And the port configurations here that we're doing are, again, for the overall port and what ties mostly to the global domain parameters. So as we go through this, you're going to notice that the ICCP protocol is very picky between the connections of the server and the client. A lot of these different parameters have to be verbatim or the exact same from one end of the communications to the other. So the best idea or best practice is going to be just copy and paste what you have from one side. If you have one established system already, try and match up with that one just to keep things simple. So for the first example, what we're going to do is we're just going to start working through this, and we're going to do a little explanation of each field as we go through here. So we're just going to call this one Power Hour for our description. Now the AP title, as we get to this, is the application process title. So this is just a description of the bilateral table that's going to be used here. And so we're just going to start working our way through. It's there's a little bit of a syntax that goes to it, but we're just going to type this in for this example. This is what we've been testing with on our side. But it's a field that, again, has to match from one side to the next. The next one that we're going to work through is the AE qualifier. That stands for the application entity. And again, this is just another a field here that we're going to put in. So we're just going to go ahead and put an example of one. The P cell, or the presentation selector, is part of the OSI table in the groups that Chi showed earlier. And so again, these are defined to be optional parameters here, but again, best practice to go ahead and put in something, again, as long as it matches from one end to the other on the ICCP protocol. So for this example, we're just going to follow this syntax. This just happens to be something we have. The S cell stands for the OSI session selector. So this is going to be kind of a similar idea here. So we're just going to type in these values. And you'll notice that for some of these, there's actually a space between these. They're in groups of 2 characters as you go through. So just be aware that the space is actually being utilized in here. It's not omitted at all. And then lastly, we have the T cell, which stands for the OSI transport selector value in here. And again, we're just going to put in some values, keeping these in mind. Now, as we go through here, the SBO, or the select before operate timeout, that's the standard value there. That should, kind of go back and tie parallels to, similar in the DMP protocol, the select before operate. And then lastly, we have the critical report timeout. Again, default of 5 seconds here. Now, we have the ability, as Chi said, to do just direct-to-direct connections. This is going to be fairly rare, so we're going to leave this one unchecked for now. And then importantly, the good majority of the time, bilateral tables are used, as Chi mentioned many times, within the ICCP protocol. So we're going to keep this example in place for today. And that's going to go ahead and work for us. Now, by default, the ICCP protocol is working across port 102. So if you're going to implement this protocol, keep this port in mind, as this may be something that needs to be added to any of the firewall rules in your enterprise. If we do enable the TLS wrapper for encrypting all of the traffic, please note that as we select this box, it actually changes that port. So it actually enables port 3782 here. So if you do change that, keep that in mind. And then if we were to be doing the encryption, which is not going to be covered in this power hour necessarily, we have covered some of the certificates in the past, so you can reference that. But this is where you would put in the links to those certificates hosted on the Orion. So we're going to go ahead and leave it at this for now, and we're going to go ahead and click accept. And we're going to jump into and do just a little bit in the global domain, and we're going to do the majority of our work in a new domain, so keep that in mind. We'll define why in a little bit later. But if we click into the new global domain, you'll see we have the ability to add data sets if we need to, if that's part of your ICCP implementation. But to keep things simple for today, we're going to go ahead and just do this in the base here, just in the global domain inputs and outputs outside of the actual data sets. So the first things that we're going to do is, in typical NCD fashion, everything that's available is going to be on the left. These are all of the points that are already defined and configured in the Orion real-time database. And so it's just a matter of grabbing stuff from the left, sending it over to the right. And you'll see a few fields that are created. And we're going to come back to these and define these in the next stage, because we're going to have a little bit more information. But the important thing to note is that we have the Orion point name. These are all of the points that were defined as we created all of our devices that the Orion interrogates from all of the Orion's client ports. But then ICCP reference points are created. Now these points, or these definitions, references, links, tags, whatever you want to call them, these are the most important fields to pay attention to, because these are the labels of the data that have to actually match from one end of the ICCP communications to the other. So from one system to the next, these tags are the references to the actual data stored over here on the left side. Think of these possibly as, like the DNP point numbers, etc. You'll see we don't have any actual point numbers in this protocol. Everything is referenced by these unique tags or fields here. So again, these have to match verbatim from one system to the next. So that's going to tie through. If we click into outputs, same idea. It's going to look the exact same. But what we're actually going to do is, as I've mentioned earlier, we're going to go ahead and get out of the global domain, and we're going to actually create a new domain for doing a unique connection from one Orion to the next. So as we go into ICC1 here, as I click the first new domain, you'll notice a lot of these fields here are referencing the exact same idea as what we had over in the global area. So what we're going to do is we're going to follow suit and do really similar to that, but you'll notice you can go a little bit unique here. So I'm just going to go ahead and name my bilateral table ID. We're just going to call this example. And then in the AP title, I'm going to follow that same style of syntax. And again, if what I'm typing in is not making a whole lot of sense, go ahead and refer back to the user manual in here, and it'll give a little bit more description of these different fields for you. But again, the most important concept here is to still copy from one system to the next. So I'm going to go ahead and follow suit, and instead I'm going to go ahead and put in 2 here just to make it a little bit unique instead of the 1 that we did on the last side. I'm going to do the same thing on my qualifier. And then in my the remaining presentation, session, and transports, I'm going to go ahead and just copy what I did before, keeping it on the same OSI style table. Importantly, click accept at the top. We're going to update this and click yes, and that's going to configure my domain. Example, ICC1. And now we're going to go into the inputs. And I'm going to do everything else in this case from my Orion IO. So we're going to start, since I put these guys over in the global domain, I'm going to grab the rest of my inputs. I'm going to send them over to the right. I'm going to grab my analog inputs. And now we're going to go through some of the definitions of all of the different point types that are available in here. So you'll notice we're going to start with the analogs just because that's on top here. But if I go to the point type now, we've got a few different options, if you will. So we're just going to start from the top. This is really more for a binary, so I guess please don't let me confuse you there. But the different point types that we have are the state 1 bit. That means just a single bit binary point. I mean, basically self-explanatory there. That can just be a 0 or 1, off or on. When we come into the state 2 bit, this starts to mimic other protocols such as like the 104 protocol and other ones that have the 2-bit states. So if we have a 00, that's going to often mean between, a 01 might mean a tripped, a 10 might mean closed, and a 11 might mean invalid. Where do we get those? Like the best typical example is if we use some logic within the Orion and we want to create some of these points, typically we'd be monitoring, the best field case use example would be monitoring a switch or something where the 2 different bits are represented by the 52A and the 52B contact, meaning you can monitor to see if a switch is actually closed or open by each of those points, or if the switch is actually in motion during a transition from a commanded close or trip. If you're reading a 00, that would mean the arm is actually still in transition between the 2 states. So you can use it for monitoring that. The last few examples, again, now applying more towards the analogs themselves, is that if you have a discrete analog type, that's going to be an actual numeric analog value or an integer-based, again, similar to what you typically see in DNP or Modbus. And then lastly, if you have a real type, now that's going to allow floating points and allow decimals. So in this case, since we're using the Orion IO, we're just going to go ahead and leave these in the discrete because that's going to be our integer representation of this. And then, of course, just because of our binary inputs on our Orion IO, that best applies towards our state 1 bits. So we're going to leave these as they are, but again, just wanted to define those different point types for you. Lastly, again, kind of a parallel to DNP, we can adjust our deadbands if we need to, meaning if the counts on these values changes by a value greater than 3 now, it's going to, the ICCP protocol is going to send these values over as a reported change. So that covers getting some of the points into our input field. Again, in typical fashion, you can sort along the bottom by specific point types and get to just your binary points or just your analog points if needed. But that shows for all points. Now, if we jump into the outputs, again, everything available on the left, I'm going to go ahead and send it over to the right. Just to keep going along with the different point types, you'll see every point here is listed as a command, but the other values that are available, these tie more towards the analog outputs. So a command is just self-explanatory. It's for a binary point. But the SP, real, and discrete set points, just in parallel to what we just did on the inputs, the discrete is going to be for your integer-based value, and then your set point real is going to be for your floating point type. So again, we're going to leave these all as command. Now, the important field that does need to be entered here is the this field here for the select before operate. This just needs a value. In my mind, I like to think of it as a check or an ID or something. It's just this value, again, from either end of the ICCP protocol needs to have this matching. So what we can do is we organize these. I can just come down through. They could all be 1. They could all be, the same number. It doesn't have to be unique. It's just I need to put something in this field in order to make these outputs complete. Now, again, the select before operate checkbox is undone at this point. That's the default state. If I do want to enable that, then I can go ahead and add checkboxes, but for this example, it's not going to affect us too much, and we're going to just leave it as this. So that completes basically setting up the inputs and outputs and building the domain inside of our Orion. So what we can do now at this point is we could essentially save this file. So I can go ahead and do a file save as. You'll see I had my LX base. I'm going to go ahead and just keep this on my desktop, and we're going to call this my LX. We're going to call that ICCP. And we're going to go ahead and save that. And then now would be time to move on to configuring the client port. Now, to make things very easy for us as far as doing an Orion to Orion ICCP configuration is that if we come back to the port option here, you'll see a button that's available for export to default file. So I can go ahead and click that, and it's going to say, you know, which domains do I want to export? This is going to be that ICC1 that we just configured. I press OK, and I'm going to go ahead and give it another name. We're just going to call this ICC1 Power Hour for something identifiable. And this is starting to follow the exact same idea of creating default templates from other protocols. You'll see that as soon as I did that, it's going to say the file was created, it's located in this directory, restart NCD to start using this file again. So with everything saved, I'm going to go ahead and kill NCD. We're going to go ahead and open it right back up and let it reload. And so now I could open up LX ICCP again if I wanted to, but most importantly, we're going to go to File, New, and I happen to have an Orion LXM sitting on my bench as well. So we're going to go ahead and build this, but we're going to start building the ICCP client port now. Again, available only in this beta version for now, but we'll go ahead and press OK. We're going to leave these as defaults. We're going to add a new device. And again, NovaTech ICC1 Power Hour, the file we just created. I go ahead and click Accept. And we're going to import this domain for us. And basically, a good majority of all the work is already done for us. You'll see all of those same parameters that we had. If I open up the ICCP Server port on the left, you're going to notice my conventions. Everything I'm going to do is going to be the LX on the left, and I'm going to keep my LXM stuff over on the right. So server, client, but all of these values were already imported for me. So the device one, you'll see all of the parameters over here are already matching. Bilateral tables are selected, etc. All I have to do in here is, since we didn't define any IP addresses, I just happen to know that the IP address of my LX is this. So I'm going to put that in, click Accept, and we have that configured. Now, if I go down through the domain, ICC1, you're going to see all of those same values are configured over here automatically from that template. And now it's just a matter of going to my inputs. I'm just going to select everything, throw them over to the right. Again, you'll notice everything is in here with some extra stuff that we may have been forgotten. We did have some of those points we put in initially within the global domain as well. And so those points are shown with checkboxes now stating that these points can be pulled from that global domain. Now, in the same idea, we'll go over to our outputs, grab all these points, send them over to the right. Get no global domain checkboxes here, no SBOs, and you'll notice those same IDs are imported as well. So at this point, we have essentially matching configurations. So what we can do now is, just so that, because we created only a client port on my LXM, just so that these show up for testing purposes, I'm going to go ahead and go back into my LXM. I'm going to go ahead and configure. I'm just going to do a DNP server port just to try and treat this as a dummy port. I'm not even going to actually configure anything as far as the parameters go in here. I'm just going to go into my inputs. I'm going to go to my ICCP client. I'm just going to grab all these points, send them over, my outputs as well, and that way these points will show up in my data values when we load these files. So ignore this. In fact, we're even just going to call this the dummy port. We're going to ignore it, accept it, And now with the ICCP configured on both my server and my client here, I can go ahead and again, file save as. We're going to call this on my desktop, again, we're going to call this the LXM ICCP. We're going to save that, and we're going to start loading these configurations onto Orion. So hopefully at this point, a lot of this should be a little bit of rinse and repeat for you guys if you're familiar with the Orion platform already. But opening these web pages, again, here's my Orion LX. I'm already logged in on the left. Here's my Orion LXM on the right. And we're just going to go ahead and load these files. So here's my LX ICCP. I'm going to open it, send it, and then I'm going to activate that file that we did, LX ICCP. Do the same over on the right side, send it, LXM ICCP, activate these files. And the first things that we can do is that as these are loading in and the files are activating, you'll notice I have a few different tabs opened already, is I can click over to my devices tab and you'll see that I am indeed pulling my Orion IO with my LX. If I come over into my LXM here, you'll see it's still waiting to boot up right now, but the ICCP client is initializing in the background right now. And then if we go into our data values, you'll see that the ICCP server is waiting to go. You'll see the inputs are in here, reading everything from the Orion IO right now. And if we come back to our devices, it looks like I may have done a typo somewhere. Chi, if you saw it, let me know. But if you're doing some of this troubleshooting, what you can do is you can come back in and you can see the, again, come back to the inputs and you'll see a list of all the different points.
Double check the bilateral
I
ID.
did the wrong file.
Oh.
Oh, yep, see, that's what I did. Apparently I had some other stuff. Here's LXM capitalized. Let's go ahead and load that in there. And let's activate that one. Guess I should have deleted old files here. So be aware of your file names. Fun little troubleshooting there. Let's go back to our devices, and as that's booting up, we should see that come alive here in a second. But what you can do is, again, you can come into NCD, and I actually have some connections configured already to my Orion LX and to my Orion LXM. So I can connect to the LX here. I like to log in as root because that way it keeps my sessions open all the time. If you have this permission enabled, you can type NTSH to get to the NovaTech shell and you'll arrive at this familiar window. You can come into view communications and you can go to your ICCP server and monitor this. And then in similar fashion, we can come back here, go to your Orion LXM, connect. I'm going to do the same idea. Log in, NovaTech shell, view communications, and we can go to our ICCP client and we can watch some of our configurations here. Now, it looks like I still may have done a typo somewhere. Did you by chance see?
Sean, check the bilateral ID that you had on your server side. I believe it might have to be a number and not a, I think you had text on it. BLT ID there.
Mm-hmm. That's just got to be a number?
Yeah, try that, and then on your client side, make sure it's a number as well.
Perfect. You know what? I think that might have been it. So we're going to go ahead and save those configurations. We're going to put those in. We're going to load those back. Oops. Apologies, everyone. Get those loaded over there. And then, again, that's a perfect example of for testing purposes, as those files load, you can come back to these configuration or these sessions, and you'll notice they didn't kick you out entirely. It just bumps you out of the NovaTech shell, so you can quickly come back in here, type NTSH, and it'll dump you right back there. So if we go back into our web pages here, you'll see the devices. Chi is the ICCP guru here. So again, the quick note, please don't put in text for your bilateral table ID. Let's keep those numerical. But at this point, we can go back into our sessions here and view communications, port 4. View communications, we're going to go to port 3, and you can actually see everything communicating back and forth between the Orions. So you'll see it's asking for all of the different binary analog points going back and forth here. Again, you can use this for troubleshooting if needed. Returning back to our devices on the web pages now, what we can do is we can go into our points. We can even go to the highest level if we wanted to and view our dummies. We can go into our outputs. I can go to the data values, even all the way down on my Orion IO. This is basically going on either side of the ICCP protocol at this point. We can go ahead and find one of our points. Let's just do the top one here. We can force that latch to a 1, confirm it, and we should see that change happen over here on the left side, which just took place. And that is a quick example of how we can implement the ICCP protocol between Orions with a little help from Chi there to save my butt on the text fields there. But the last thing that we did create that I do want to go back and show is that we created our default template there when we created our server port and then exported that over to the client. So if we go into our Explorer, if we go into our Documents folder or wherever you have your default files set to within NCD, so you come in here and here is our ICC1 Power Hour. So we can go ahead and open up this file. Sorry, looks like I went to my other monitor, so I'll bring this over. This is the file that's created, again, by NCD3 and exported, and what the NCD software uses to build the client port. So if you come through, it might be a little cryptic, but at the very top, this is going to be some of the port parameters. Down here is going to be some of the domain parameters itself. Notice that some of the things are separated into different columns here. And so if you're trying to decipher what one is from the next, is you can actually come back, look at NCD, you can go to your actual port here, your ICCP server, and then kind of do the parallels between these. So you'll see here's the domain, so we'll come into the ports. You'll see how everything's in here with the AP title, for example. It's separated out into different cells following those commas. If we come down a little further, you're going to see all of the inputs that are available here. If we come into the inputs, you're going to see how those correlate between all of the different values here. And then lastly, on the outputs being fairly important as well, so that if you come there, you'll see that we have the tag names here, the domain itself, the type for the point type, the SBO is a 0, meaning it's unchecked. There'd be 1 if you had a checkbox. The check ID on here, we have all of those values, and then of course the mins and the maxes for those. So what you could do potentially is that you'll notice that the server, as we were building it, it didn't necessarily have all of the little green pluses for adding all of the points that you would do typically. So what we're recommending is that you can use these template files, modify them, save them as something else, do all of your editing within this spreadsheet, and then import it back into NCD. Some of the advantages of that is that because you're in here and you're obviously within Excel, ideally, if you have another system on the other side of this protocol that's already configured, you guys would be able to then share the ICCP reference names from one another, and then it's just a matter of copy and pasting. So then you're reducing the potential for errors and so on. So again, just to summarize, the majority of your configuration for the ICCP client can be done in here for those Orion to non-Orion scenarios. Again, if you need this side. If you're doing just the server for the Orion, then you've got it made and you can pretty much ignore everything I just said for the last few minutes. But closing that kind of wraps us up as far as the demonstration. Chi, if you have anything else you think we should jump into, please let me know. But with that, that's kind of the quick summary of how we can build ICCP between the two Orions, and then a theoretical idea of an Orion to a non-Orion device. With that, just the typical ending slides for us, just to remind everybody, for those of you who have not joined already, please find us over on power.novatechautomation.com for our power support community. Please request an account on there. It's a manual approval process. It might take a day or two tops, but inside of this you can find many different items, that being some of the articles for common tech notes. You can find firmware, software, all of the power hour recordings, etc. Booking.novatechautomation.com. You can book one of us sales engineers. If you need a session, you want some personal one-on-one style consultation, technical problems, just overview, anything, you can go ahead and get on here and book a time with any of us sales engineers. And then lastly, this is Chi and I's contact information. If you guys have any other questions, please feel free to email us directly. As far as everything else goes that we've shown today, I believe we're going to, per Ray, right, I think in July or by July, we're going to have documentation submitted out for the ICCP client, so that should be made available to everyone. But again, Chi, unless you have anything else, everyone, thank you very much for joining us today, and we will see you in another 2 weeks, I believe, for a 61850 expert mode presentation.
Awesome. Thank you, Sean. Thanks, everyone.
All right. Thank you, everybody. Take care.
Bye-bye.